AI agents are everywhere right now. These are more than chatbots that answer questions. Agentic AI systems can understand context, work toward a goal, and take real-world action through connected tools and services with limited or no human intervention. You tell the agent what you want done, and it determines the steps and carries them out. That can deliver a major productivity boost. It's like having a team of intelligent digital employees working at speed and scale. But handing control to an autonomous system can expand your attack surface overnight. In this video, we'll examine the biggest security risk of letting your AI operate on autopilot and the controls needed to prevent it from steering your organization off course. Let's begin with local self-hosted agent platforms. These platforms make it easy to run autonomous agents directly on a laptop or workstation. But under the hood, an agent or one of its skills may execute code with the permissions granted to its host process, potentially including admin or root privileges if it's launched that way. Some agent platforms also support custom skills from public registries or code repositories. Those skills may contain malicious code or exploitable vulnerabilities. Once executed, a compromised skill could inherit the agent's access to local files, browser data, stored credentials, and command line tools. Consider someone who stores passwords in a spreadsheet. A compromised agent could read that file, open the browser, access sensitive accounts, transfer data or funds, and then execute commands that damage the device. This is why local autonomous agents should never run directly on a standard personal or enterprise workstation without strong isolation. Some of the most dangerous attacks against AI agents may target human judgment rather than software vulnerabilities. AI agents often communicate with confidence, authority, and polished explanations. That can cause users to lower their guard. If an agent is compromised or manipulated, it may not attempt to bypass security controls directly. Instead, it can create a logical and persuasive justification for a harmful action, then ask a human supervisor to approve it. The user trusts the agent's reasoning and clicks approve without independently verifying the request. Because a human technically authorized the action, the system may record it as a legitimate event. The action may appear legitimate in a conventional audit trail because a human approved it, especially if the system does not preserve the agent's reasoning, context, identity, and tool call history. This makes the breach harder to detect, investigate, and trace back to its source. The risk increases when multiple agents begin working together. In multiple agent systems, agents communicate, delegate tasks, access shared memory, and interact with connected applications. If agent-to-agent communication lacks strong authentication and validation, compromise can propagate beyond a single agent. An attacker may only need to compromise one shared memory file or instruction source. A malicious instruction may store a persistent file and survive system restarts and quietly influence future decisions. Because agents operate through fast autonomous loops, a single compromised action may not remain isolated. It can spread through APIs, databases, applications, and peer agents before a human operator can respond. A small error at the beginning of the workflow can quickly become a large-scale security incident. So, how do we secure the autopilot? Organizations must stop treating AI agents as ordinary software tools. They should be governed as highly privileged non-human employees. That requires 3 core security controls. First, strict identity governance. Every agent should have its own unique non-human identity and credentials. Agents should never share passwords, service accounts, or API keys. Second, just-in-time access and least privilege. Agents should receive only the permissions required for the current task. Those permissions should be tightly scoped, time-bound, and automatically revoked when the task is complete. Third, an AI firewall or security proxy. Interactions between users, models, and connected tools should pass through a monitored control layer. This layer can screen for prompt injection, deterministically validate and authorize tool calls, enforce policies, and monitor outputs for sensitive data exposure. These controls help contain compromised agents before they can affect the wider environment. Autonomous agents have fundamentally changed how we work. but autonomy without boundaries creates unacceptable risk. Before an AI agent acts on your behalf, make sure its identity, actions, permissions, and communications are properly controlled. Because in the age of autonomous AI, responsibility still belongs to us. Thanks for watching. Secure your systems, and I'll see you in the next video.